Hello, my name is Dr. Churla, and today we are going over CNCM Online Round 3, Problem 2. All right, let's just get on to it. This is my problem that I wrote for this contest, and we'll go ahead. So, the problem reads, consider a rectangle ABCD with AB equals 6 and BC equals 8. Pick points E, F, G, and H such that the angle AEB, BFC, CGD, and AHD are all right. What was the largest possible area of quadrilateral EFGH? So obviously, first step for doing these types of problems would be to draw a diagram. So let's just draw one right here. Let's say that this is, I'm going to draw this horizontally just so we have space to draw. So this is going to be A, this is going to be B, so this is going to be 6. We can kind of draw the other side length. It's going to be C, D, that's 8. And so we pick points E, F, G, and H such that angles AEB, BFC, CGD, and AHD are right. So basically, they're points. We pick one on like corresponding to each side. So like this one would be point E. It's right, right angle. This would be point H. It's a right angle. But yeah, and you'd want to find like a quadrilateral of that area, but we want to find the largest possible area. So to start, we should probably erase this because this is not the optimal one. You actually want to prove what the optimal one is. So let's try this. So for all of the right angles like for a point to have a right angle with A and B, and A and B has fixed length, the point E would have to lie on a circle with diameter AB. And that's just one of the well-known facts. I don't know what the exact name of the theorem would be, but it's not hard to see. Basically, any point with a right angle will lie on this circle. Similarly, we can do this for every other side, and so you get something like this. It's hard to draw circles on this. Let me just try, keep on doing this. So I'm drawing each of these to make a point here. So as you can see, we have this. Points E, F, G, and H have to lie on basically these circles. As many of you guessed, it's actually the 45, 45, 90 case that's optimal. Where E is here, F is here, G is here, and H is here. What I mean by 45, 45, 90 is that this is a 45, 45, 90 triangle because this is like the midpoint of the arc. This is what most people guessed, and that is, you know, the right answer. This quadrilateral is the largest possible area, but we want to prove it. And that's why we have these circles in the first place, to show this. I should probably draw it better, but this is a square, by the way. It's a square. But we want to show that this square is the largest possible area that you can fit in here. So what we're going to do is we know that this circle has radius 3 and this circle has radius 4. Let's take the center of the rectangle here and let's draw a circle with radius 7. So if you're to draw the circle of radius 7 around this whole diagram, not a great drawing, but the largest possible area of a quadrilateral. First, let's say this. The points, every single set of points E, F, G, H will be contained within this circle. You can't be outside of the circle. Everything will be contained within the boundary of this circle with radius 7. So, it's also known that the largest possible area of a quadrilateral that you can fit in a circle is a cyclic square. It's easy to see. It's not too hard to show. I won't be showing it here if you want. You can look at it on your own time. But that is the largest possible area. It makes sense logically too. That is the largest possible area that you can fit on a circle. And any other set of points, won't match this. This is the largest possible area you can fit in a largest possible area of quadrilateral you can fit in a circle. regardless, so there's nothing else for us to show. So it would just involve us finding the area of this quadrilateral at this point. Well, this is a square, as we've said earlier. And there's two ways you can find the area here. We know that this is 7, and it's the right triangle, so this is going to be 7 root 2 right here. That side length is going to be 7 root 2. Since it's a square, you can just square 7 root 2, and you'd get 49 times 2, 98. You can also take the diagonals. This is a square, you can take the diagonals. If you felt like doing it this way, they're each 14, so the area would be 14 times 14 divided by 2, which would be 98 as well. The answer is 98. And that is it for our solution video. I have a slide here. So this slide, so if you haven't already, we have a Discord server, great Discord server, 1,500 members. If you need any help on any math problems or any content in any one of our videos, you can join our Discord server right here. I'll put the link in the description. We also now have a handouts page. And some of you may have noticed that some of our prior lectures, previous lectures, like our most recent ones, have included handouts to go along with them. And so we haven't actually had like a place on our website to put those handouts, but here they are. They're here, and you can look at them. So that's all I have for today. Thank you all for watching, and I'll see you next time.